I should start recording.
I just did, sorry. Hey everyone, welcome to SIG Node meeting on September 16th, 2025. First up we have Sergey.
Yeah, I just wanted to say that release dates, I think it's official right now, but I'm not sure. Like there is a enhancement freeze, release will start in a couple of days, I think. And we started the project board. We also have our Wranglers program to track caps. So if you think your cap is planned for 135, ping somebody who can apply milestone, and we can put it in proposed state, and then we can have a cap review at some point and planning for 135.
Great, thank you. There's nothing else on that. We can go to Eric and Don.
Eric.
Yeah. Hi, I'm Eric. Wanted to give SIG Node a heads up that in SIG scheduling, we're planning an alpha in 135, and Node doesn't have to do anything, but it does add a field to pod, which is interpreted by kubescheduler. I know SIG Node likes to understand what's happening in pod, so I just wanted to give a respectful FYI. And there's some notes in there, and I'll be on Slack if anyone wants to dive in. But it doesn't. You don't have to actuate it, so I don't want to take more time in this meeting. Thanks.
Great, yeah, thanks for the heads up.
Thanks, Eric.
All right, continuing on, Yuan?
Hi, yeah, I want to get some initial feedback on this proposal for restarting the entire pod for container. If I could share this, great.
Yeah, I just made you co-host. Should be able to.
Thank you. Okay, thank you. We in the last release 1.34, we introduced another one cap that allows a container level restart policy, and which can add more flexibility on what we can do when the container exits with a specific exit code. We also have this restart pod planned in our roadmap discussion. It's often desirable to restart the entire pod when our container exits, in contradiction to what we have nowadays for our container level restart. This has several advantages, such as we allow init containers to rerun, preparing a cleaner environment. It also has simplified the application sidecar logic. For example, sidecars could be monitoring the service health and can just exit to restart the entire pod instead of communicating with the main container to do the restart. Also, it's more efficient than deleting the pod, creating a new one, waiting for the scheduler to happen, and reinitializing everything, including network, device, sandbox, etc. Some other improvements might be it improves the predictability and debugging, because since single container restart can be affected by other running containers, and init containers are not running again. So it has several advantages here. In the use case below here, I also linked relevant issues. We have, restart pod can help with resolving all these issues and enhancement proposals. For example, here we have a request to rerun init containers when container exit on error. On the second one here, we also have another request that wants us to restart the entire pod. And on there's also another proposal in the job API, job batch API, that can help with the LLM training workloads to just restart in place when one of the worker fails. This have a great cost saving advantage, and yeah, these are basically the reasons on why I want to have this proposal. And yeah, any feedback so far?
Thank you, Rian, for sharing this one. We need to look at those holistic way, right? So there are certain use cases they want to restart the entire pod, even restart from init container, but certain use cases they don't. Right, so some is just container itself and maybe run into some problem, and those transient problem you don't want to restart from the, because that's the disruption, right? So you don't want to restart from init container completely, because init container maybe take a really long time. So that's why we need to look at this holistic instead of just ad hoc add another policy. But I totally understand there's use cases you just described that even like the other in the past proposal. So let's come up to all those kind of use cases and all together and to revisit, re-examine existing what we want, right? So we added a static container, also change some start policy, and then we recently in place pod restart, also change some of those kind of things. So let's just examine all together and then say, okay, what kind of policy, how user can have what's the default, right? So previous behavior maybe is default, but then what kind of the additional expansion about the new policy we proposed, and then start from the init container, all those kind of things. So we can talk about those kind of things to follow up. Yeah, but I understand your requirement here. Yeah.
Yeah, I think we discussed this whole holistic API last time when we did in-place restart. Yeah, maybe you can share this document. Yeah, it has many scenarios altogether.
Yeah, yeah. This is the discussion we had on last release. Yeah, here are. Let me see. Yeah, here. So last time we had this implemented. Sorry, let me find here. So we have implemented this restart policy on the container level and restart policy rules, actually. Restart policy rules. So based on some based on some container exit codes, we can give it different actions to take. So different. So currently we only have restart, which means just restart the container. Here are the few other things that we wanted to implement and think they are useful. First one is complete. So the container will just exit as if it succeeded. The second one is terminate pod. So if this container exit, then we will just terminate the entire pod. Restart pod is the one I'm proposing today. So restarting the entire pod, including the init containers on the same node. Yeah. If you want to take a look, here are all the different combinations we have for init containers on different restart actions.
I remember last time I also mentioned that because it's too late to present to the SIG Node, we want to unblock alpha. So that's why we did mention that. I'm glad this time we present those earlier, but we do agree last time to unblock alpha. So we just basically didn't really think about all the other scenario. We just need that go, right? So that's even like the Jordan also admit we are rushed to, because we know there's the high demand for in-place pod restart. At least like more than 1 year ago, I already mentioned that we need to have this feature. So we do need to think about all the scenario, all those kind of things, and repeat those kind of things. I believe we agree upon this one. Last time say, oh, let's have this alpha as soon as possible. We don't have the time to revisit. We don't want to block that alpha. Let's just get in, and even like in this SIG Node community, we agree, because there are many other questions, right, from the community. Then we send it in, and we got some user inputs. But for the next release, let's look into those kind of things and revisit all those holistic use cases. Could be all is working. That's the best of it. But we do think about the last time it's too late to talk to the SIG node. Yeah.
Sounds good.
I think the next actions will be write it down as a cap and get more feedback, and also refer to this document so to get even more feedback from community. And yeah, we will have one cap going into beta, in place restart. It's a proposal at least, and a restart pod is something that proposed to go in alpha in this release.
Thanks. Thanks, everyone. Yeah, feel free to take a look at the documents and ping me or leave comments. Yeah, I'll prepare the cap and send this out for review as well. Thank you.
Thanks, Jude.
Great, thank you. Next up, we have Bing, who's not here due to time zone, but we were asked to, propose this document basically. So there's the proposal to extend the image service to both have prioritized image pulls as well as pause and unpausable image pulls. So basically when we're pulling a very large image, that would throttle other, or that would stop other images from being pulled at the same time. And it seems like there's some desire for a preemptible image pull. So yeah, I haven't I haven't seen this yet, but I think the request was just that we look at the document and comment there. Does anyone have any initial thoughts on it?
So Michael.
Hi. Yeah, we've had a couple of discussions over the last month or two and before about different kinds of policies for image pulling, as well as the ability here to do a pause. It's an interesting subject. The layers, though, they're shared across other images. So this is going to need a work group. We're going to have a lot of discussions on, what can we really do here? We also have lazy pull, that sort of thing involved. I see Morale's got his hands up.
Hey, can you hear me?
Yeah.
Okay, all right. So one thing I would worry about immediately without reading this document is like, if we pause something, what is the interface for pausing, and what does that do to the kubelet loop, which is trying to bring up the pod, right?
My understanding is actually, it seems to be being done all within the kubelet. So upon getting a pod creation request, let's see. So incoming image pull request. So basically each image pull has a priority, and then
Okay.
That priority then preempts. So it's all done internally in the kubelet, basically.
Okay. So like, I think, yeah, I'll read through it. But the second question is like, why is this policy separate from the pod's priority itself, right? Like, why would we introduce another knob? Like, can I have a pod with a low priority, but with very high image pull priority?
Yeah, I think I agree that having the single priority be the pod-based one could be useful, and then we would only in the kubelet add and CRI add support for pause on pause, and then
which already happens, right, by scheduling and ordering. So
a little bit, yeah, but it the scheduler isn't aware of how long it takes to pull an image. So if an image is like 100 gigabytes and it's taking forever to pull, it'll be assigning pods to that node, and those pods won't be able to start. There's a bit of a queue. I'm not sure who went first. Maybe Don?
I think I'm analyst. There's the cases could be that the image priority, pulled image priority is not the match of the pod priority, because in the pod they also have the multiple image, right? So each image could take a really long time. So they also have the subtle difference with the priority. And also we cannot simply also based on the container image, because the main application maybe have the higher priority normally, but the problem is main application could be have the dependency on the init container. So all those kind of things is not that easy. Another thing it is when you pause, it mean later we are going to resume. How long you are going to resume? You could create a lot of like a cascading scenario, right? So some is relatively less important, but still they need a bounded. They are not like immediately in the field. They bounded some timeline. Then later, are we going to allow their adjusted priority and finish the job? So all those kind of things. How long we are going to the pause image could be also triggered. Do we want to evict those images? How? Because today, even like the Kubernetes, we are not proactively evict the image, right? We are based on the disk space, and we have the threshold, and then we evicted those kind of things like the periodically, because we also worry about the immediate of the evicted image, and there costs a lot of the CPU usage. All those kind of things need to consider. So it's not just simple like the priority. Simple part of the priority can address those problems. Just want to say that. Yeah. I haven't read the design yet. Maybe design all cover all this scenario already. Yeah.
I think I'm gonna yeah, just repeating what Don said, priority. I think there might be many requests on priority in terms of let's start downloading images for current pods that are not yet needed, but like during init container execution, we will start downloading images of regular container. This kind of priorities may be accounted for. Today we do everything synchronously. Like we wouldn't download image for regular container while init container is running, and the desire is to enable this kind of features. But I wanted to also talk about general SIG Node roadmap. We have all these requests and all the big images used in GenAI, where weights being distributed, where images or models are quite high, quite big. So one of the question I have is how much we as a community need to improve regular image pool, and how much we need to start looking into alternative image pools, like for instance, all the image streaming solutions, StarkGZ that on Containerd, like other companies have other ways of distribute images. And we see more and more customers doing like disk attach with pre-pulled image, pre-pulled and extracted image. And this disk attach is not an image pool, but it needs to instruct container runtime to pull images from both places somehow. And in Containerd, for instance, you'll need to implement a separate snapshotter for that and completely replace default snapshotter, which is complicates the setup quite a lot. We also have a lot of problems with this approach when we attach stream images with credential distribution, because regular image pool assumes that credentials are not needed once image is pulled, which with streaming solutions, you will need credentials throughout the life cycle of an image, because credential, like you will keep streaming from the same place. So all this, what I'm trying to get to, like, I'm trying to assess the importance of this work of improving regular image pool versus trying to improve other ways to pull images. And I'm curious to hear feedback from a community. Like, do you see how much do we need to invest here in regular image pool, and how much do you see us exploring alternative pool solutions?
Yeah, I definitely see what you mean. I find myself generally hesitant about image streaming generally. Like a lot of the solutions end up being on the file granularity, and frequently these models are very large files, which means you don't actually benefit that much from a streaming. You have to go on the block granularity or something, which I don't personally know if any of them do. But also, like, creating the network latency dependency at runtime also introduces a bunch of challenges. So I think like the guarantees of like the current image pull infrastructure of like once the container starts, you have what you need and you can keep going. I think there is utility to that. And even though these like very large, I mean, I think the real question is like, do we think that it makes sense to be pulling these large images from remote sources? I do like agree that the attach solution that seems viable and seems like, you know, or like having additional image stores be able to be plugged into the runtimes so that, you know, if in a cluster, someone could set up a separate disk and then just plug that into the node with the images. I kind of find that to be more viable than the image streaming piece of it, but I do think that I think that this specific, this extension does, I do think that the original image pulling infrastructure, if we continue to package like models in images, I think that there will be some utility in improving it. But like, I don't think it's like, you know, worth not improving and like, you know, fully going towards a streaming solution personally. But I don't know if other people have any thoughts. Yeah. Mike.
So yeah, we can talk about it. I can try to get you on the side of the paging kind of alternatives to bringing in just the indexed portions of an image that are necessary. It's a way that we've done in operating systems for, you know, swapping out for a very long time to make sure you can run your applications with minimal memory involved, and then only bring in the pages you need, right? So there is benefit, especially for large executable applications that don't hit but 5% of their code. And the same thing could apply also for very large language models where they're only going to be addressing one particular portion of the contents of any particular layer. But so, yeah, I mean, there's pros and cons each way. I agree with you, being able to plug in and having that requirement against the other runtime to support the, you know, the multi-drive kind of multi-image you know, setups. That would be nice. I think we definitely need a work group here, Peter, to go over a whole bunch of proposed caps for image services. Now that we've got ensure secret, what's next?
Yeah, what is me about this proposal is it feels like we're saving on peanuts and introducing a whole lot of complexity here. And I wonder how much we need to ensure that it's actually making a difference, and how much we need to invest into next level solutions.
Maybe Mac, your proposal to have a working group is a good idea. Because we've been talking about several proposals in the past, but we didn't really invest. The reason it is
right.
Not one problem. We have the multiple problem. We need to look at it as the whole, right? And systematically address those things. And this proposal looks like the really promising, but still, I didn't read. I just opened, and so maybe this is a good start. We need to have some working group. I'm not sure who want to take that lead and to have that working group. And then we find people, because I did really surprised they found the Node LifeCycle working group make a lot of progress, and so I feel like, okay, working group, actually maybe we need a working stream, and then came back with the holistic view, yeah, and also a list of the items, and then we help to prioritize and address them one by one.
May I ask, for all those options that now you have shared, will you also touch security aspects, or?
That's why I mentioned the insured, because yeah, we're doing a lot of work on security too. So.
Yeah, and there are requests about mirror pods and understanding how to pass credentials to mirrors. maybe mirrors needs to be concept upstream to Kubernetes itself rather than container runtimes. There are some requests about how to detect whether, like, where image was downloaded from. Like there is a CAP proposal on adding the source where it's downloaded, like exact mirror, because customers concerned about, like, customers want to double check whether image is downloaded from mirrors they configured it for, or it's downloaded from original source for all sort of cost and security analysis. So yeah, security clearly one big aspect here, and I'm a little overwhelmed with number of caps and people trying to patch existing API here and there, and it's all adding complexity.
Yeah, I think having a working group to just sift through all of the different, or even have some separate meetings, like a handful of them, not even like an official working group, to just sift through the existing caps and decide, okay, what is the direction that SIG Node wants to take image pulling in? Could maybe be an interim solution.
And talking about that, Peter, there is a garbage collection cap as well that is waiting for GA, but I don't know whether we have any.
Yeah, I saw your
feedback
comment on that, and I have yet to think of a reason to go GA. Like, I'm guessing we probably will end up reverting it in thinking about it. But yeah, we can talk about that on the cap as well. Cool. Okay, so I think the feedback here is that we as a SIG need to sort of come up with what we believe the direction of the image service generally is before we like take this on, because we might just be patching on top of something that maybe needs a little more thorough review. So we can maybe put that in the meeting notes, and it's obviously in the recording as well. And we can talk about it more in some follow-ups. Cool. I think next up we have Victoria and Rashidin from Checkpoint Restore side.
Yes. Hello. Would it be possible to share my screen? Hi.
Hey, welcome.
Yeah, co-host now.
Yes. Okay. Yeah. So I agree. So this is a follow-up on the discussion we had last time. So essentially, our goal is to present some of the use cases that we have and ask for advice on how to essentially limit the scope and how to prioritize some of the tasks. So just just to briefly cover what is the current state of checkpointing. So we can essentially create a checkpoint of individual containers. These checkpoints are saved as star files that can be converted to an OCI image, and this image can be used to essentially to start a container, to resume the container from a checkpoint. We also support GPU checkpoints. This is completely transparent, so we don't have to make any changes to Kubernetes. It's implemented with CRIO using plugins. And some of the main use cases are infrastructure level fault tolerance, for example, for long-running applications or training jobs, or essentially HPC applications, for example, that run for long periods of time. You can essentially create checkpoints periodically, and you can use these checkpoints to resume the application in the case of failure. You can also create a snapshot after long initialization time, for example, with Java applications. And then you can use this checkpoint to essentially start the application in already initialized state. And this is commonly used to essentially speed up the application's startup time. Preemptive scheduling is another essentially use case where you have different, different workloads with different priorities, and you want to preempt a particular workload, but you don't want to lose the state. For example, if it is low priority, long running tasks. you can use the checkpointing mechanism to essentially snapshot the current state of the application and then to resume the application on different node from this checkpoint. And load balancing and migration is common use case, for example, during node maintenance, where you want to move all the nodes, all the pods from particular node, and to, for example, update the operating system. And forensic analysis is another use case where you can, for example, create a checkpoint, and then you can use this checkpoint to analyze what an attacker has been doing at a particular point in time. And we have some command line tools that can be used for this. So we had a brief discussion in Slack, and essentially Peter suggested that we can start with pod level checkpointing. So this is something that many people have requested as a feature, because currently people have to checkpoint individual containers, and this is mainly because we took the implementation from Podman and Docker, and Podman and Docker use containers. So checkpointing a pod is something that will be very useful, but we still have to discuss what would actually mean, how it would work, and there is there are different ways of implementing it. And another item is essentially introducing an explicit restore API. So essentially allowing users to restore containers. For example, using a local API. Later, we can extend this to remote API. And essentially, we can integrate these APIs with other, for example, other systems. And I think Peter can probably expand more on this. This is essentially the comments that he posted, and I'm just interpreting them. But another phase that we can later on look into is how to encrypt checkpoints, how to compress the memory pages of a checkpoint. For example, if you checkpoint a training job, most of the GPU state is stored in memory, and this is usually very large. And then during migration, we have to preserve the IP address of the job that the pod that is being migrated. And Victoria also suggested that adding resource quotas for checkpoints, for example, per namespace, limit range, or per project, is something that can be very useful. So this is just to briefly summarize the discussions that we had.
I just one comment. First comment, you make a previous discussing even more complicated. You checkpoint as the image, right? So what's the priority? To pull that image on another node because you want to do the migration, or it is just as the walnut store on the walnut and the detach and attach. So all those kind of things actually make the previous discussion is more complicated.
Yeah, I think that will be part of what the discussion ends up being with the restore piece. Like, what does restore actually look like if we do it officially, rather than like right now we're kind of hackily putting in restore by having it be in an image. So yeah, but that's definitely true.
Mm-hmm. So you end up, because you want to using priority, originally you maybe do the setup. You don't worry about the startup latency, but the program is run in the middle. Now startup latency really matters. Are you going to bump up the priority, and how are you going to bump up? So this is everything is complicated. Image pooling priority is complicated. Anyway, I'm just waiting for this one finish and say that. Yeah.
Okay. Thank you. Yeah, I think it really depends on the use case. For example, if we want to migrate a pod, then we want to reduce the downtime of the migration. And then if we just create checkpoints for fault tolerance, then we don't restore these checkpoints. So it's just the checkpointing mechanism. And then forensic analysis is completely separate use case. So it really depends on the use case, I think. And we have to implement something that can be used, is generic solution that can be used for different use cases.
Yeah, and I personally, like the way that I'm imagining like checkpointing in the future is like focusing on either the migration or like as a form of pausing a process for preemption. So like there are a number of cases where it would be useful to like not fully stop a process and then restart it from the beginning, but rather like freeze its state, move it somewhere, or like wait on it, do something else in the meantime, and then restore it. And I think so, like, to me, that feels like the most like important case to sort of optimize for. I don't know if other people have any thoughts.
One research, one thing that we recently did as a research project was to essentially checkpoint inference workloads, for example, VOM. So the problem is inference workloads take a long time to initialize, essentially to they implement different types of optimizations that improve the throughput of inference serving. And so if you create a checkpoint after the inference engine has already initialized, you can essentially resume the inference workload significantly faster. You can reduce, for example, from 1 or 2 minutes to a few seconds. And this is something that can be used also for scaling. For example, if you want to increase the number of inference workloads. I'm not sure if this helps, but it's just something that we did recently.
Oh, actually, I'm interested in this one mostly for the inference jobs. So, Redis team, can you just add the link to your slide deck? So then there also have a lot of open questions. Right? So, I mean, not open questions. There are a lot of the problem we need to address to make that is the cluster a while feature, right? So today, we have the basic minimal features put by at the node, but if once you want to checkpoint restore, make the cluster aware of the checkpoint restore, even go crazy and for pod live migration automated, there are a lot of things beyond node that we need to address, right? So for example, for network, IP address, all those kind of things. So yeah, we are looking forward for this, make more progress. But just like what I mentioned earlier, like the network storage problem, we need to figure out scheduling problem, how that work with the scheduling of just reusing scheduling, and it is using the all those kind of things, and the controller integration also need to consider is beyond node. And so that's why this is one after we finish that the checkpoint restore, we suggest the SIG app take over, right? So that's kind of, but on the other hand, we are going to working on the image management, right? So the image management, that's also could be SIG Node blocker for you here, right? So because you really want zero downtime, right? For those inference jobs, but how you make those, you checkpoint, package it as the image, and then how you make sure available and other ways, right? So that's you could be just like the, also there's the discussing about the for those kind of things and for the init state and the checkpoint, right? So then then basically it's not like the pod level migration, instead it's just saving init state, reduce the init state of the startup latency. So then, but how those kind of things work together with the autoscaler, HPA, and rest of the system, that's also need discussing.
Yeah, thank you. This is very helpful, and I agree with you. I think we need to kind of focus on the simple questions that we can answer, and then later on we can.
Can you just share the slide deck here? Yeah.
Yes, I will do that now. I just want to check, Vicky, do you have any, or I see a few hands. Mike, do you want to go next?
Yeah, I just wanted to throw in that Peter piqued my ears. He mentioned pause. Pause would also, we need to add additional states, both to containers and to pods. And I think that would be something beneficial to add.
Yeah, I didn't necessarily mean like pause on the sense of the OCI runtime, but more of like from the perspective of the workload, if you checkpointed and then stopped it and then moved that checkpoint somewhere and waited to restore it and then restored it, it would look like it was paused internally. It could like look as though, okay, I was paused and then like resume. And that behavior I think could be useful. So I'm not necessarily suggesting, I mean, we could think about introducing OCI pause, but then those resources would continue to be used. And I think that would be less useful for the cases that I'm thinking of, where it's like, okay, we have a new workload that wants to preempt existing workloads. How do we disturb those existing workloads less?
Which is all somewhat related to the prioritization stuff we were talking about. Maybe there are some pods that could be serialized out, or maybe we just want to start them all up, pause them all, because we need more CPU, we need more resources to be able to initialize stuff, usually, than we do to actually run them, right? Especially if you're doing Knative, you know, microservices type operation.
Yeah.
This also is quite interesting. So what we did, another experiment was to essentially checkpoint on the GPU state. So what we can do is, for example, if you have multiple inference jobs, we can checkpoint one inference job into host memory, and then we can pause it. Essentially, we can leave the container in a pause state, and then in this way, we release the GPU that can be used by other jobs. So we can serve larger number of models with fewer GPUs. And the main goal is to reduce the cost of serving, but it's kind of related to the pause functionality.
Yeah, one suggestion here is if you take in, like, first we need to understand priority of all that, and I also very interested in inference stuff. Inference may be related to auto scaling or preemption and pause, as you said. For auto scaling, when you have an inference that's fully initialized and you want to take a copy of it and then replicate it multiple times, for this scenario, I would, and for any other scenario, like if you take in scenarios, let's just try to discuss what would be the end-to-end look like. For replication, for instance, you need to have API for workload to say it's ready to be replicated, some callback, like maybe some API calls to start serialization and like checkpoints, and it somehow need to tell that it's done. If you're talking about pause, then probably we need to change some API on DRA. So DRA will allow to allocate the same devices for preempted, like paused port, and then give them away to something else, and then restore back to original one. So this DRA API may need to be changed. So whatever scenario we'll pick, let's discuss priority and then discuss what the end-to-end will look like, because this is what we actually seeking for here. Like if we have an end-to-end, we understand all the gaps, and the problem right now is we can enable one feature like checkpoint, and then this checkpoint doesn't work with any other scenarios. Like you are really missing a lot of things, and it's became a like very complicated do-it-yourself kind of solution all the time.
Thank you, Sergey. I also want to ask you about, essentially had kind of related comment on the pull request about, I think the application to be able to trigger the checkpoint, essentially having an API that does that, or is that correct? Or?
I don't remember specific comment, but yeah, we need to like. My desire is to get the end-to-end. Like if we have an end-to-end explained, like how it will work, it will be much easier to have further conversations. And we have two goals, right? So find a scenario for which we want end-to-end, and second one, make sure that this end-to-end doesn't break any other solutions, and it can be extended later for other scenarios as well.
Thank you so much. Kevin, do you want to go next?
Yeah, I mean, I had a comment just like you had your phase one. I do want to make sure that the checkpoint API is, to me, like that's probably why I like the forensic checkpoint. Like we even see it's challenging to enable forensic checkpointing if we don't have an API. So like that is like for us, phase one of this would be a proper kube control, or like a REST endpoint for checkpointing, I guess pods or images, I'm not sure.
Yeah, I disagree with the phasing there, because we don't currently have pod level checkpointing, which is why in the list that Rastadin posted, I believe second one was API, but the first one I think should be pod level checkpointing, because we don't currently have that. So I think like, because Kubernetes so frequently thinks on the granularity of pods, I think we should first get the pod level checkpointing stuff straightened away, and then we will have a better idea of what the API looks like.
Yeah. This was actually the first thing on my list. So pod level checkpointing.
Right.
Yeah,
So
in your slide, you say pod level checkpointing with the kubelet API, and
right.
what I'm trying to say is I think we would want like a REST endpoint for checkpointing going forward, and not use the kubelet endpoint.
Maybe we can talk about this offline. From my perspective, the API piece of it is less important than having it behaviorally work the correct way on the underlying. So like if we design the API to be container level and then are eventually moving pod level, that'll break the API. But if we define the actual behavioral piece of it, of having it be pod level, and then we can define the API, that'll be a longer standing API. But we can discuss maybe, I mean, when we have like more, the hope really, and I think the what I want people to take away from this conversation is that there's a lot of work to do here, and that there is promise to this work in terms of the things that the direction that the SIG is going, which is basically a way to advocate. I do think that it's useful to have the working group, and like I don't necessarily think we need to reestablish that here because we did already, but like as Rasta did and Victoria go through the SIGs that are involved in the checkpoint restore feature, and eventually in the working group, the goal is just to say like, here are relevant pieces of work that we're thinking about, and this is why we think we need to pull everyone together for the working group.
But I do feel we need to figure out, we want to go further we want to start from the pod level checkpoint or container level checkpoint. That's the API level, right? So the first API level, because the complexity actually is different. Both have the complexity, but it's different, right? Container level, you could just checkpoint. You could start the pod remotely. Then the dynamic pod, we haven't prioritized. Dynamic pod could add the container into, but then that's the network impact also is different. Storage is different. Pod level also is different. But pod level, then we could say, oh, this pod is suspend and or destroy, and then just basically kind of evicted and then start from a different place. So there's some like the complexity. It's just totally different layer of the complexity.
And my position is like, eventually, I don't know if this is the case, but my perspective is like, eventually we want to move towards pod level checkpointing. We have currently container because that was like the first step, but really like pod is the end goal. And for that reason, I don't think we should design an API before we are at our end goal.
One question I have is whether we should be checkpointing the init containers or not, or how.
Right, and this is exactly the question that, like, for a pod, you would probably not checkpoint the init containers if they're not sidecar. If they're a sidecar, you should checkpoint them because they're running at the same time. But it depends on the phasing and like when in the pod life cycle you checkpoint it, and that's like a question we'll have to answer of like, okay, you start a pod, it's running in an init container, and then you checkpoint it. Like, what should the behavior be? Probably, like, from my perspective, a pod getting checkpointed should look, from the pod's perspective, as close to it was fully CPU throttled as possible. Like, imagine a world where like the CPU request wasn't done at all, and there was no CPU for that pod all of a sudden, and that pod like pauses fully, and then it starts again because CPU gets available again. I think that that's what it should look like from the perspective of a process inside of that pod, if you checkpointed it. And so whatever we can do to get to that end goal, I think would be amazing. There are probably reasons why it won't work perfectly in that way. And I know one that's already been called out is like, okay, do we migrate the pod IP? And how do you do that? But like generally my perspective is that we should like focus on that like North Star in terms of the behavior of what a pod level checkpoint looks like.
I think we have too many items today. This one, this is super interesting, but we also have other interesting topic today. Can we just run through them? I'm couldn't wait for eviction request.
Yeah, I agree. Let's move on and work more maybe offline and in a working group. Philip, you want to present eviction request?
Hey, yeah, I will try to make it quick. So I edit the changes to the pod API to the CAP, like with which we discussed last time. And also folks at Uber went ahead and did a POC of this feature. And so like we had a presentation from them in the last working group meeting, or not lifecycle working group meeting. So if you want to check it, how it will look like, it's available now. And so I think like we've had like some like discussions about this feature in the working group and in the CAP reviews. And I think there is like a consensus that people would find this feature beneficial. Like there is still some like minor things needed in the CAP to fix, but I think the major shape is there of the feature. Yeah, so we would like to ask SIG Node if we could track it for 135.
Yeah, I mean, I think I'm personally open to tracking it in 135. I think the CAP still needs a couple of, like, I see it's still in status provisional, so I think we need to update some pieces in the CAP and probably have more conversation there. But it is exciting to know that Uber, folks at Uber did implement the API, and I think that that'll really help move forward the conversation for the CAP. So I definitely am personally open to it. I don't know how other people feel.
Thanks. So I watched the demo yesterday, and please add your link to your demo to our agenda, right? So point people in case people want to see, because the demo is the whole meeting is so long, 1 hour. So at the end, in the middle, there's the demo. Right? So my top concern is adoption, right? So because we are required to change a lot of controller based on those kind of design, right? So a lot of those things, and another thing it is so is there any plan about this adoption and how without adopted like some cluster, some controller will implement require of the API, some controller didn't. What it is the legal behavior. So it's a little bit unclear to me from the current design, right? So the happy path is just everybody accepted. This is really cool because it's coexist even with today's eviction API. But there's some like the hybrid mode of cluster, what it is behavior. I haven't clearly say that from the design. Another thing it is like the small concern, but all those kind of things because have this kind of the scalability and performance concern, right? So that's kind of the could be like in the beta. I just want to make sure we are going to do those load tests and all those kind of and heartbeat toning, all those kind of things. Yeah, and I think that's my top concern when I watch that demo and read the design. Yeah. But pretty exciting because one more thing is I think this is definitely solve the problem for the leader. The leader, what's it called, that leader worker side, right? So their problem, but can we have like the clearly exam against those kind of things? Say this is for sure in the design, and for sure I was almost want to comment in the CAP and say, oh, can we just for sure, and can we have the example? This is solved using like the leader worker side as example. Maybe I just come up there and say how we're going to address that problem, because that's kind of top one in my mind. I hope this can address the.
Yeah, I think like the main part is that like this feature is designed as totally as opt-in. So even if like people do not come on board, like it can solve like the hard use cases like from the beginning, and like we can gradually on board, like all of the components or like the node drainers that we have in the cluster. Yeah, so we had like these discussions sideways, like on the adoption. But I guess it would be better if I maybe dedicate like a whole section in the CAP like to the adoption, for the adoption, and yeah, I can highlight like what is the plan and how we will proceed there.
Great. Yeah, was there anything else on that topic? Cool. We are at time for this week, so thanks everyone for a really full and productive meeting. And
Thank you.
take care, everyone.
Thank you.